So w minus w1 divided by w minus w3 times w2 minus w3 over w2 minus w1 is equal to the similar relation on C. All right, so now what we're going to do is we are going to look at an example where we do this. So we're looking for this transformation that maps 2i negative 2 to 1i negative 1. First, remember here's the defining relation, right? So this is the map that sends z1, z2, z3 to w1, w2, w3. And in our particular case, we have z1 is equal to 2, z2 is equal to I, z3 is equal to negative 2, and w1 is equal to 1, w2 is equal to I, and w3 is equal to negative 1. So our first step is going to be replacing all of those values into the above equation. So why don't you pause, go ahead and do this. You plug in all the values of w1, w2, w3, and z1, z2, and z3. This is the equation you're left with. Right, so again, what I'd like to point out is the fact that there's going to be a fraction where you have w's, a fraction where you have z's, but the rest are going to be complex numbers. So now it's just a matter of simplification. So remember, we are trying to solve for w is equal to some function of z, right? Because that's what our Mobius transformations look like. What I'm going to do is I'm going to clear the I plus 1 divided by I minus 1 on the left-hand side by multiplying both sides by I minus 1 over I plus 1. Right, so when we do that, when I multiply both sides by I minus 1 over I plus 1, on the left-hand side, we're left with the w minus 1 divided by w plus 1. And on the right-hand side, this is the equality we're left with. That's the portion there. Right, so, and then now what I'm going to do is I'm going to simplify the expression there. I see I squared floating around. We know I squared is equal to 1. So when we simplify that, we're left with this expression here. Right, and now it's just a matter of cross-multiplying and simplifying. Right, so this is some nasty business here. It's going to be some nasty algebra, but we are looking for something of the form w as some function of z. All right, so again, like I said, what we did here was we multiplied both sides by the reciprocal of that, and on the right-hand side, when we do that, we had I minus 1 divided by I plus 1. And so that's what we have. So that's what we multiplied the entire expression by. Now what we're going to do is we have two fractions on both sides, so we're going to cross multiply everything, just expand everything out and collect like terms. So in the first step that you already see there, what I've done is I've cross multiplied those two expressions there and gone ahead and multiplied it. So what I would suggest is pausing this video here, trying to simplify this all on your own, and then come back and check your answer, because this is something you need to get comfortable with, and it's just, I would like you to get some practice doing this. All right, so we cross multiply, then we expand everything out here, so I'm going to multiply both sides out, and then now I'm going to cancel the terms that show up on both sides. That's what I'm left with. Next step is going to be collecting all the w terms, all the terms that have a w and the ones that don't have that. So if you move everything around, that's what you're left with. So the ones on the left are the ones that have w, the ones on the right are the ones that don't have w. And then factor out w and then divide both sides. So this is the Mobius transformation, a unique one that maps 2i and negative 2 onto 1i and negative 1. Right, so again, here's the thing, but what I would suggest is I'd suggest pausing this video and working through it on your own to make sure you get to this answer here.